Hello everyone and welcome back to my channel. Today we will see how to create this particular geometry, and to do this we will use a plugin of Grasshopper called Crystallon that let us create first a voxelization, so a division of the space, and then to apply some unit cell to this voxelization. First of all, you have to download Crystallon that you can do freely from Food for Rhino, and you find the link in the description. And at the end, we will obtain a very interesting geometry like this. And it is a very easy tutorial because I only use the base of these plugins. You can reach with these plugins a high level of modelization, but for this tutorial we will use only the basis. Hello everyone and welcome back to my channel. Today we will see how to create this particular geometry, and to do this we will use a plugin of Grasshopper called Crystallon that let us create first a voxelization, so a division of the space, and then to apply some unit cell to this voxelization. First of all, you have to download Crystallon that you can do freely from Food for Rhino, and you find the link in the description. And at the end, we will obtain a very interesting geometry like this. And it is a very easy tutorial because I only use the base of these plugins. You can reach with these plugins a high level of modelization, but for this tutorial we will use only the basis. Let's start creating a circle. We create a slider to the radius, to define the radius. Now we divide this curve. We put 100 under n. Okay. Now we want to move up and down these points. To do this, we can move in direction Z of an amount defined by a graph mapper. Right click, graph types, sign, and we increase the number of the waves. Now we are seeing it to Z. Now we have to create a range of value that is exactly one less than this counter. We have math, operator, subtraction. On B we put 1. And we connect the R output to the N. Domain is from 0 to 1. It's okay because it's the same of this. Let's go. This is okay. Now we are going to create a section curve to create this whip. And so we can do curve primitive circle CNR. We create a circle and we evaluate a point on the curve. Evaluate curve. We evaluate a point here, the circle, at 0.5, for example, and we make there the circle because we have the tangent here. The tangent of the curve will be the normal of the in which the new circle is created. But pay attention, we have to work on this new curve. So we create interpolate curve. Okay, and so we have to give this interpolate curve to the evaluation. Now we have a binary curve, and then we have the section curve. We can do sweep 1. We have section curve. We have rail curve, and then we have section curve. Okay, this is our geometry. Now we are going to voxelize it. We use Crystallon to do it, but first we need another surface, an inner surface. So we can create offset of surface, and I give distance, for example, let's try 10. Let's see what happens. Okay, it's too much. Okay, we should drive it by floating point number 0.2 slider. Let's say on D. Okay, it is going better. So this is my inner surface, and this is my outer surface that I'm going to work with. So I open Crystallon and I voxelize creating a voxelation between surfaces. This is my command, and I click Shift and connect both the surface to the MBS. Now we are going to assign the X parameter, Y parameter and Z parameter. You can see that in input the request is a range of number of floating point number. So first of all we create a range, and we leave the domain, the basic domain, that is 0 to 1, and in number we give the number of voxel we want to create in the X direction. I put 60. Then I copy and shift the slider to 5, and I copy another time and I shift to 3. Now I assign the first range to Tx, the second range to Ty, and the third range to Tz. Now I'm going to select the previous part of the definition and the spacebar, and disable preview. Okay, now what we can see is that our geometry, basic geometry, is divided in different volumes. You can see voxels that are sort of volume of the space that we will fill with the populate part. If we go to the Crystallon, we have a populate, that is the second step, in which we will fill these volumes with some crystal, some lattice geometry. So if we change this, you can understand that it will change the way the space is divided. Okay. And the x direction is the length of the curve. The y direction, you can see here, is the concentric direction to the main curve. And then we have the z, that is the number of division in a radial direction. At less we have 2 is the less we can choose. Okay, now we are going to populate. So we create a lattice fill. So we select Crystallon, Voodoo lattice fill, and we connect the voxel to the voxel input. You can read voxel to be filled with unit cells. Okay, and now we have to create the unit cells. We have to create these cell types, and then we have to create the Crystallon Voodoo cell selector, and then we connect the output of this to the US, and then the U to the U input of GLF, and then we are going to select the crystal we like more. So we undo preview. It could be nice, but we can choose between a lot of other proposals. Okay, this one is the one I will choose, but there are a lot of others, shapes we can choose. And the point is that we decide to create lattice surface. So this is a lattice crystal based on lattice, and you don't have you only have to consider that there are two kinds of space subdivision we can do, and one is lattice, the other is shell. So in this phase, in this moment, you have to select, because we are working on lattice, we decide to create a lattice geometry. You have only to choose this part of option. When you see shell, is not you cannot not choose that kind, because it will give error to us. It will create a problem to the subdivision. If I select shell, it became red. So you can only choose between this the upper options. Also, this is nice, it's very nice. But you can decide the unit cell you want. I will use BC cubic for this tutorial. Okay, and now the part in Crystallon is finished. We can just apply a pipe, because the result is a list of curves. So if I apply a pipe to the curves, it will create a pipe around each curve. Okay, it will take some time, but at the end we have this. This is now, it seems to be a problem because the radius is too high. But if I decide to reduce this the radius of 10, I will obtain a better result. Maybe after we have to further reduce these values. It's like this. So we go to 0.0105, and we go to the, and we link to the radius. When you have so many elements, the time can be, the time of working of the computer can be very much. Okay, we have to reduce more, so we go to 0.01, because I want this part to be very thin. You understand how these shapes are 3D printable. Now I'm changing the radius to 0.01. Okay. This is the effect I wanted to obtain. Now we can. What I want to show you. This is our unit cell. The unit cell we decide to create. So the voxel basically is the external shape, and the unit cell selector is how do we fill this space. Now we bring the geometry in Rhino, so pipe, right click, bake, choose the layer where you want to put the geometry, and click OK. Now we hide all the geometry in Grasshopper. To do this we click on the upper right part of the canvas. Don't draw any preview geometry. OK. And now we go to renderize on Rhino. And this is our result. You can see how every pipe is perfectly connected with the other. And the geometry is working well. So, if you like the video, if you enjoy the video, likes under the video, and subscribe to my channel.